Hello, my trig mathematicians. We just got done talking about inverses today in class, and if you watch the Nearpod on inverses, hopefully you got a little more theoretical and analytical and kind of understood where it came from. We've definitely rushed it there at the end, and that's okay. We're just going to roll with the punches and do the best we can. So, I did not show you everything with inverses that I wanted to show you. I am going to wrap it up here. We'll get that second part of the stamp, and then we can practice a little bit of inverses. So, without further ado, let's talk inverses. I am going to start with showing you guys my calculator. All right, a little bit of calculator work never hurt anyone. Make it a little bit closer so you can see it. It's bigger. Inverse operations are operations that undo each other. If I start with a 6 plus 5 and then I subtract 5, I'm left with just a 6. Right? We knew this. 6 times 15 divided by 15, just the 6. How about the square root of 6 squared? Works as long as it's positive. I typed it in funky. Yeah, I didn't like that. The square root of 6 squared. How about that? Yeah, it just leaves me with 6. Those are inverse operations. So if I do something like take the sine of 6 and then take the inverse sine of 0.10452846333, I get really, really close to, just because of some rounding issues, what I had originally plugged in. They're undoing each other. So if I took the inverse sine of the sine of 6, we just get back what we started with. No big deal, right? There is some exceptions here. I'm going to show you this. What's the sine of 30? If you don't know it off the top of your head, I'm not totally bummed out, just a little bummed out. It's 1/2. 1, 2 square root of 3, right? So if in my calculator, I put the inverse sine of 0.5, what should come out? It is. It's 30. No big deal. Okay. Well, what's the sine of 150? Also 0.5. So if I did inverse sine of 0.5, wait, we already did this. I should get 150 out, right? But I don't. That's because we're not in the restricted domain. That's what I talked about. 150. These angles that we're using have to be between negative 90 and 90 for this to work. Your calculator is in this agreement, has been programmed to only give us answers between negative 90 and 90 when we're using inverse sine, and 150 is not. So it gives us the same value we would get as if it were 150, sine of 150.5. Okay, so that's kind of the idea, but let us move on. Okay, here's what I want to talk about, and I just showed you guys a second ago. As long as we are in the correct domain, we're in the restricted domain, we can say that the arc sine of a sine cancel each other out, and you're just going to be left with whatever you're left with. No big deal. Okay? If you are not in the restricted domain, then we need to find something that's coterminal, or that would have the same sign as that angle, so that we can play this game, inverse sine canceling with the sine. These would not cancel each other out. The inverse sine of the sine of 5 pi over 3 is not 5 pi over 3, because 5 pi over 3 isn't in our restricted domain, right? Between negative pi over 2 and pi over 2 if we're in radians. So that doesn't work. We need to find an angle that's coterminal with this, or has the same sign as this, that is in our restricted domain, and then we can apply this little cancel it off rule. So there's 5 pi over 3. Easy enough. I went clockwise, positive direction. Well, instead of doing that, I could just go in the negative direction, 1 pi over 3. And now we're talking the same angle. We have the same starting point, same ending point, coterminal. Negative pi over 3 is in my restricted domain. So I would get negative pi over 3. The inverse sine of the sine of 5 pi over 3 is just negative pi over 3, because those are coterminal. Okay. All right. So here's the use substitution. Here's what we're going to talk today. This is a little trick we use in pre-calculus quite a bit, in trigonometry a little, and that's why I'm showing it to you now, but in calculus a lot. You will do this method called use substitution in a lot of things in calculus, so it's good that we're going over it, okay? We want to find the tangent of some angle. Remember how we read this. This is saying there's some angle out there that has a cosine that's 2/3. This, in general, is talking about an angle. I want you to find the tangent of that angle. Ignore that. Okay. To make this happen, this is a big messy problem, and this idea of u substitution helps us to kind of clean up big messy problems. Instead of taking the tangent of arc cosine 2/3, I'm going to make a u substitution, and I'm going to say, you know what, wherever I see arc cosine 2/3, this messy part, just what's inside of here, I'm going to call that a u. So now before, where I was looking for the tangent of this mess, if I do this u substitution, I'm going to let u equal arc cosine 2/3. I'm not trying to find the tangent of this mess. I'm just trying to find the tangent of u. And that looks a lot neater. Tangent of u, I can handle that. Okay, so back to our little u substitution. Let's remember this. Put this in our back pocket. This is what we're trying to find. We let u equal the arc cosine of 2/3. So if u is the arc cosine of 2/3, I'm going to pull a little shenanigans here and say, you know what, I don't like all that arc cosine talk. If I took the cosine of both sides right now, just like you could add 2 to both sides, or you could divide by 7 on both sides, I'm going to take the cosine of both sides and the cosine of an arc cosine, arc cosine, undo each other. That's what we just talked about in that first note. So I'm taking the cosine of both sides, the cosine of u is now the cosine of arc cosine, but those cancel each other out. And I'm left with this kind of phrase. The cosine of that angle we were talking about, u, is 2/3. I'm trying to find the tangent of u. If you know the cosine of u is 2/3, find the tangent of u. We've done that problem before. Okay, so cosine is adjacent over hypotenuse. I'm going to draw my triangle. I'm going to do the Pythagorean theorem. C squared minus a squared equals b squared. That's why I'm subtracting them on this one. We get the square root of 5. Now we've filled out our triangle. We're not done. But remember that thing we had in our back pocket? It was the tangent of u. What I'm actually trying to solve for is the tangent of u. So nowhere actually in this problem are we finding u. I'm not trying to find what that angle is. I'm trying to find the tangent of what that angle is. And tangent is opposite over adjacent. Square root of 5 over 2. Done. Okay. So it is. It's pretty similar to what we've done in the past, just a little bit differently. Okay? Let's try another one. This one's going to have variables in it instead of numbers, but it's the same idea. Very calculus-like. I want to write an algebraic expression. That means there's going to be x's in my answer. That would give me the sine of the arc cosine of 3x. Okay? So arc cosine of 3x is some angle. It's u. Right? There's our u substitution. U equals arc cosine 3x. There's some angle that has a cosine that's 3x over 1. It worked out better up here because this was 2/3. It was a fraction. That helped us with the adjacent and hypotenuse stuff. On this one, I'm just going to have to remind myself that's actually 3x over 1. So here's my u substitution. I'm letting arc cosine of 3x equal to u. So now remember what I'm actually trying to find is the sine of u, back pocket. Now we'll handle this one. I'll take the cosine of both sides. If I take the cosine of both sides, it looks like that. And the cosine of arc cosine cancel each other out. We'll just have 3x. And then there's that over 1, so we can have a fraction. Nice. Okay, so there's some triangle out there. I could draw it. It's going to have an angle of u. I don't care what u is right now. I just know the cosine of u is adjacent over hypotenuse. Okay. Then I can do the Pythagorean theorem just like before. A squared plus b squared equals c squared. I rearrange it. C squared minus a squared equals b squared. I'm actually trying to find the sine of u. Sine is opposite over hypotenuse. And look, I'm going to get a marker because I already see something I didn't put in there. This is that angle we were talking about. This is u. We don't care what u is because we want the sine of u. I don't have the answer either. Okay. Sine of u is opposite over hypotenuse, so it would just be square root of 1 minus 9x squared. Okay. There's a second part of the stamp for you guys. I want you to try them out. Bring them to me the next time I see you, and we'll go through them together. And that's it. That's inverses. Moving on.